that is interpolation. Interpolation. So, what is interpolation and the application of interpolation? Suppose we have to find out, suppose the population of a country is available of the following years. Let us suppose 1987, 1997, 2002, 2007, etc. Yeah, and population. Okay, some population are given to you for the year 19. What is the population in 1987, 1997? That means the data is given to you after every 10 years. Okay, and suppose we are interested to compute population in the year 1992 or 2000 or suppose 2006, etc. Okay, so the data of the population is given to you for the following years, suppose 1987, after 10 years 1997, and we are interested to compute the population in between any of the year. So what we do for that, we'll try to compute population in between the year by applying interpolation. So the process by which the population of the year, suppose 1992, 2000, 2006 can be obtained is called interpolation. It's called interpolation. That means not only these years, any year in between, that is called interpolation. So in between the range 1987 to 2007, if we want to compute population in any of the years, then we will apply the procedure interpolation. So this is the application of interpolation. So how to compute these values or the population in these given years? For that, what we do, we'll try to approximate these values with the help of some function. What would be that function? That function could be polynomial or any function. By the data we can check what kind of this data behaving. If it is behaving like exponential, then we'll take exponential function. If it is behaving like trigonometric function or any function, then we can use those functions. But the best way is what? We can use polynomial. Why polynomial? Because the most useful and well-known class of function mapping functions mapping the set of real numbers into itself is the algebraic polynomial. Polynomials. Right. Suppose Pnx equal to a0 plus a1x plus a2x square and so on an x, where a0, a1, a2, an are constant and n is an integer. N is a non-negative integer. By polynomials only, because polynomials are having a special quality that polynomials approximate uniformly approximate continuous function. Second thing is what? Derivative and indefinite integral of the polynomials are easy to obtain. Means what? Like the most useful and well-known classes of function are what? That is the polynomials, because these polynomials are having the properties that they can approximate any continuous function. And the derivative of the polynomials and the integral of the polynomials are easy to obtain. That's why we are approximating any function with the help of polynomials. Let's talk about the polynomial. Suppose there is some function that is not easy to integrate. So what we do, we can approximate that function with the help of polynomial, and then we can integrate polynomial, because polynomial integration is very easy. So there is a theorem that is called Weierstrass approximation theorem. According to this theorem, approximation theorem. What is that theorem? Suppose f is a continuous function. Defined in the interval a to b, then for any epsilon greater than 0, there exists a polynomial. Px defined on AB with the property that fx minus px is less than epsilon for all x belonging to AB. That means any function that is continuous and defined inside the interval AB can be approximated by a polynomial px such that the error between the function and the polynomial is what? That is very, very small. So any continuous function can be approximated with the help of a polynomial. So this is the Weierstrass approximation theorem. Then according to Weierstrass approximation theorem, there is a very little error between the function and polynomial, So this if we approximate function with the help of polynomial, then polynomial are easy to deal. That's why we are interested in polynomial. So next thing is what? How to approximate a polynomial. Next is how to approximate a function with the help of polynomial. With the help of polynomial. Of a polynomial. So, do you know any existing method that you read till now? So, Lagrange I should write Taylor series approximation. I think everybody is aware about the Taylor series approximation. What is Taylor series approximation? We can approximate a function with the help of Taylor series expansion. But Taylor series or Taylor series polynomial, whatever we are getting Taylor series, that is the polynomial that agree Taylor polynomial agrees as closely as possible with the given function at a specific point. By specific point, suppose there is some function fx equal to suppose sin x. Okay, what is the Taylor series expansion? That is x plus x naught minus x naught. So this is the, okay, it is p of x. So what is coming out to be? F of x0 plus x minus x naught f dash x0 x minus x naught square upon factorial 2 f double dash x naught and so on. So this Taylor series expansion is what? That is about a point x0. This is Taylor series expansion. About a point x0. But we are interested in a polynomial that should be valid inside some range. Okay, so that's why we are rejecting Taylor series expansion to approximate a function fx. Okay, so another procedure is what? Another procedure we are using interpolation. So interpolation, so another procedure to approximate a function fx by polynomial is what? Interpolation. What is interpolation? Like how do so interpolation deals with the problem of constructing a polynomial px of minimum degree which passes through a given set of discrete data points. Suppose xi, yi, I equal to 0, 1, 2 and so on to n. Then the polynomial px is called interpolating polynomial, interpolating polynomial, polynomial having the property p of xi equal to yi, where I equal to 0, 1, 2 n. So this polynomial px will agree at the given point xi with yi. So this polynomial px is equivalent to y at the given specific point xi. Okay. So this px is used to determine the value of the dependent variable for any intermediate value of independent variable. So this px is used to compute the value of the dependent variable for any specific value of the, or any intermediate value, I should say, any intermediate value. Intermediate means what? That is inside the range xi to xin plus 1. Intermediate value of xi. That means suppose some data is given to you x0, x1, xn, and the y is given at this point yn. This is independent variable, this is dependent variable. And for the given xi values, yi is given to you. As I told you, like xi can be the years and yi is the population given to you, as we have discussed in the previous example. So if you want to compute value of the dependent variable at any point inside the interval, then we can find a polynomial with the help of the given data, and then we can compute the value of the dependent variable for any value of the independent variable. Okay, so let's discuss it. So given x0, y0, xn, yn, finding the value of y at any x in the interval x0 to xn, I should say open interval, because x0 to xn is called interpolation. Okay, so suppose there is some, this is the point x0, y0, the point is given to you, x1, y1, this is the point xn, yn, xn minus 1, yn minus 1. And if we want to compute the value at any point inside, we can use. So the data point are given at these specific points, and we want to compute value in between any point, then we can use interpolation. What are the method? So how to construct interpolating polynomial? There are two procedures basically we are using in this chapter, otherwise there are lot many. So Lagrange interpolating polynomial, second is Newton divided difference polynomial. Okay. So first we are going to discuss Lagrange interpolating polynomial. Lagrange interpolating polynomial. Interpolating polynomial. So given n+1 data points, suppose x0, y0, x1, y1, xn, yn, there exists a at least there exists a polynomial of at most degree 1 and that passes through these points. Let us suppose the polynomial is what? Pnx equal to a0 plus a1x plus a2x square and an xn. Now how to find out these values a0, a1, a2, an? Now the question is how to find a0, a1, an. Okay. So let us discuss about the linear interpolation. First, linear Lagrange interpolation. Suppose the data point are given to you x0, y0 and x1, y1, then the equation of the straight line. So there are only 2 points, so maximum 1 degree polynomial is possible. So equation of the line, in this case it will be what? Px, p1x will be what? a0 plus a1x. Okay, or you can say like y minus y1, equal to y2 minus, or I should say y1 minus y0 upon x1 minus x0 x minus x0. I should write it y0. Let us take y0 as f of x0 and y1 as f of x1. Okay, so y minus f of x0 equal to f of x1 minus f of x0 upon x1 minus x0 x minus x0. Now writing this y is what? That is the value of the polynomial, you can say. So the value, it is coming out to be, you can either apply this procedure or this procedure. You are getting finally, after manipulation all these values, you are getting x minus x1 x0 minus x1 f of x0 plus x minus x0 upon x1 minus x0 f of x1. It will write equation in this way. Okay, so this is called L0x f of x0. The coefficient of fx0 we are writing as L0x and the coefficient of fx1 as L1x. So the value of L0x, just compare from the previous case, x minus x1 upon x0 minus x1, and the value of L1x, x minus x0 upon x1 minus x0. This L0 x and L1x are called, in this case, are called Lagrange interpolating polynomial, or I should say Lagrange polynomial. Lagrange polynomial. If we are talking about L0x, then this value is what? This is x minus x1. x0 is not in the numerator, but in the denominator this x0, L0 is associated with x0 and x0 minus x1. Similarly L1x, then x1 will not be in the numerator. There will be the another point out of this x0 and x1 point. Okay, so x minus x1 is not here, it is x minus x0, and this is L1, so x1 minus x0. This L0x and L1 are called, these are called Lagrange polynomial, and these are having the property that, then the property of the Lagrange polynomial, L0x plus L1x, what would be the value? That means the value of this, it is coming out to be 1. Why? Because x minus x1, x0 minus x1. We can write denominator same, so x0 minus x1, x minus x0. You are getting here x minus x1 minus x plus x0 upon x0 minus x. So this is the value 1. So the first property of these Lagrange polynomial is what? L0 plus L1 is coming out to be 1. This is the first property. Now the second property, L0 xi is equal to what? L0 xi means what? Suppose x0. X will put as x0. So this is your L0x. So it is coming out to be x0 minus x1 upon x0 minus x1. The value is coming out to be 1. Now compute L0 x1. L0 x1 is what? x1 minus x1 upon x0 minus x1. The value is coming out to be 0. Similarly, L1 x0 is coming out to be 0 and L1 x1 is coming out to be 1. So we can conclude from here, Li xj equal to, when this is 0 and this is x1, L0 x1, the value is 0. Whenever L0 x0, the value is 1. So both the terms are same, Li xi, both are same, then the value is 1. If it is different, the value is 0. We can say the value is 1 or 0 as I is equal to j and I is not equal to j. Okay, so this is the property of the Lagrange polynomial. This is what? P of x equal to L0x plus L1, L0x f of x0 plus L1x f of x1. So what would be the value of P of x0? The value of P of x0 is what? X0 x0 will be what? 1 f of x0, and this value L1 x0 will be what? 0. Okay, so value is coming out to be fx0. So the polynomial value is equivalent to the function value at the point x0. This is the property of the interpolating polynomial. Lix are called Lagrange polynomials and Px is called Lagrange interpolating polynomial. This Px is what? This is Lagrange interpolating polynomial. Interpolating polynomial. And the polynomial value at the x0 point is what? Fx0. If we compute P of x1, the value is coming out to be x1. You can verify it. So that is the reason why this polynomial is called interpolating. That means the polynomial that is having, that we are constructing with the help of the given data, and the polynomial that agree with the function value at the given data point. Okay. So px0, fx0, p of x1, f of x1. This is the property of Lagrange interpolating polynomial. Next is higher degree, higher order Lagrange polynomial. For the linear case, we are getting px equal to L0 fx0, L1 fx1. We can write it here as summation Lix f of x I equal to 0 to 1. When we are having 3 points, suppose in this case we were having 2 data points. When we are having 3 data points, then we are having a parabola. Okay, now we are discussing, suppose the data points are given to you, x0, y0, x1, y1, then xn, yn. Then the interpolating polynomial of degree n can, there are n plus 1 data point, n plus 1 data points available, because x0, we are starting with x0. So maximum n degree polynomial is possible. Maximum n degree polynomial is possible. Lower degree also possible. So p of n, p and x can be written as summation n equal to 0 to infinity, 0, I equal to 0 to n Lix f of xi. Lix, where Lix are Lagrange polynomial. Okay. Now, so we can write Pn xj will be f of xj, where j is lying 0 to n. Okay, Lixj. Okay, so first write what is Lix when we are having n plus 1 data point. Lix. Just recall the definition of 1 degree Lagrange polynomial. Here you are having n plus 1 data point. So n degree Lix will be n degree Lagrange polynomial. Since it is Li, or I should write a particular L0x when n plus 1 data points are available. So x minus, this is 0, so x0 will not be in the numerator. All other points will be there in the numerator. X minus x1, x minus x2, x minus xn. And x0 minus x1, all points will be subtracted by x0 only. x0 minus x2, x0 minus xn. This is L0x. If we are writing L1x or Lix, I point will, xi will not be in the numerator. So x minus x0, x minus x1, x minus xi minus 1, x minus xi plus 1, x minus xn, xi minus x0, xi minus x1, xi minus xi minus 1, xi minus xi plus 1, xi minus xi. Okay, so what would be the property of Lixj? If it is 1 or 0, I equal to j, I is not equal to j. You can verify it with the help of this. If we are writing L0x, suppose L0 x0, what would the value in the numerator? x0 minus x1, x0 minus x2, x0 minus xn. So numerator and denominator will remain same, it is 1. If we are writing L0 x1, then what will the value of L0 x1? This is x1 minus x0. The value will be 0. So you can, similarly you can verify all other values. So I have just given the result for L0x. Now, this is the Lagrange polynomial that we have discussed already. So this is the thing. Now let us take an example. So find interpolating polynomial, interpolating polynomial in Lagrange form for the data -2, -1, 1, 3, -15, -4, 0, 20. So this data is given to you. You have to find out Lagrange polynomial. Okay, so already you know what is the, how many points are here? 1, 2, 3, 4. 4 points are here. Maximum 3-degree polynomial is possible. So L0x, f of x0, L1x, f of x1 plus L2x, f of, so there are 4 points. L2x, f of x2 plus L3x, f of x3. There are total 4 Lagrange functions are available. So this is what, this is your x0 point, this is your x0 point, this is your x1 point, this is x2 point, and this is your x3 point. And this is f of x0, f of x1, f of x2, f of x3. Okay, what is L0x? L0, that means x0 will not be in the numerator, x minus x1, x minus x2, x minus x3 upon x0 minus x1, x0 minus x2, x0 minus x3. Okay, so x minus x1, x minus plus 1, x minus 1, x minus 3 upon x0 minus x1, that is what, x0 is what, minus 2 plus 1, minus 2, minus 1, minus 2, minus 3. Okay, so the value of L0x is coming out to be, that is minus 1 upon 15 x cube minus 3x square minus x plus 3. Similarly, we can compute the value of L1x. L1x, that means it will be what, x minus x0. x1 will not be in the numerator. X minus x2, x minus x3. So we'll leave that point x1. This is a formula, this is a better way to remember this formula. x1 minus x0, x1 minus x2, x1 minus x3. The value x0, x1, x2 all are given to you. L1x we can compute as 1 upon 8 x cube minus 2x square minus 5x plus 6. Similarly, L2x is coming out to be minus 1 upon 12 x cube minus 7x minus 6. L3x, so there are 4 Lx. If the 4 data points are available, then 4 n data points are available, then n Lagrange polynomial we can form. Okay. L3x is what? That is 1 upon 40 x cube plus 2x square minus x minus 2. Then P3x will be what? L0 fx0, L1 fx1, L2 fx2, L3 fx3. Okay, so after putting all the values of L0, L1, L2, L3 and fx0, fx1, fx2, fx3 from here, we are getting P3x as x cube minus x square plus x minus 1. Now we'll check whether the polynomial is correct or not. So what we can do, we'll just check P3 x0 value. What is the value is coming out to be? What is x0? x0 is minus 2. So minus 2 cube minus 2 square plus minus 2 minus 1. It is minus 8 minus 4 minus 2 minus 1. The value is coming out to be minus 15. That is the value equivalent to fx0. So this is equivalent to fx0. So the polynomial we formed, that is the correct polynomial that will interpolate the given data. So this is the Lagrange interpolating polynomial. You can check interpolating polynomial. So this portion is over.